Question 675. Here we have a definite integral with a rational expression. This rational expression can be expressed as a sum of simpler fractions called partial fractions. In order to do that, this denominator must be factored. That's the condition. Let's try to find the partial fractions of this expression right here. So we have a 5x plus 1 over, we're going to factor this denominator, okay? That's x plus 2, x minus 1, right? And we will have one fraction with the denominator x plus 2 and another fraction with the denominator x minus 1, okay? For now, I'm going to write some constant a here, some constant b here, okay? Now, what we need to do is to find the values of a and b such that the expression on the left is equal to the expression on the right. So let's multiply all of this by least common multiple, which is x plus 2, x minus 1, right? So 5x plus 1 is equal to a times x minus 1 plus b times x plus 2, right? Now I'm going to substitute x value where this expression is equal to 0. Okay, so substitute 1 for x. So substitute 1 for x. Then 1 here, 1 here, 1 here. 6 is equal to, this is a 0, right? So it cancels out, it goes away. And 1 plus 2, that's a 3. So we have a 3b here. So b is equal to 2, right? Now substitute x value where this expression is equal to 0. So I'm going to substitute negative 2 for x. So negative 2 here, negative 2 here, negative 2 here. All right? 5 times negative 2, that's negative 10, plus 1, that's negative 9. A times negative 2 minus 1, that's negative 3, right? So negative 3a, and this expression is equal to 0, right? So we have 9 is equal to negative 3a, then a is a 3, right? So substitute 3 for a, 2 for b. This expression is equal to all of this expression when a is equal to 3 and b is equal to 2. All right? The question was to find the antiderivative of this expression, right? So what we can do is we can just find the antiderivative of this expression since these two expressions are equal. Does that make sense? Okay, so what I'm going to do is I'm going to find the antiderivative of these two expressions separately. So integral, we have a 3 over x plus 2 dx plus integral 2 over x minus 1 dx, right? So that is equal to 3 times 1 over x plus 2 dx plus 2 times integral 1 over x minus 1 dx. So that is equal to, this is 3 natural log x plus 2 plus 2 times the natural log x minus 1. And since this is indefinite integral, we have to add a c, right? This is our answer. Question 679. This time we have a definite integral with rational expressions, right? So what we're going to do is we're going to factor the denominator and find the partial fractions. If we factor this denominator, that's 2 times 2x squared plus 3x plus 1, and that is equal to 2 times 2x x 1 1, since we have 3x plus here, right? So if we rewrite this definite integral, that's going to be here 1 over 2. 1 over 2 times 0 to 1, 8x plus 7 over 2x plus 1, x plus 1 dx, right? Now let's find the partial fractions of this expression. 8x plus 7 over 2x plus 1, x plus 1 is equal to, we're going to have a 1 fraction with the denominator 2x plus 1, another fraction with the denominator x plus 1, right? So write a here, b here, and multiply all of this expression by least common multiple, which is 2x plus 1, x plus 1. So 8x plus 7 is equal to a times, 2x plus 1, 2x plus 1 cancels out, right? So a times x plus 1 plus this denominator cancels out. So b times the 2x plus 1, 2x plus 1 times b, right? So far so good. Now we're going to substitute value for x where this expression is equal to 0. So -1. So let x is equal to -1. Then if we substitute -1 here, that's -a plus 7, which is equal to -1. -1, -1. So this expression is equal to 0. And this one, -2 plus 1, right? So it's a -b. -b. So b is equal to 1, right? Now we're going to substitute -1/2 for x, so that this expression is equal to 0, right? So -1/2, -1/2, -1/2 for x. So a times -1/2, that's -4, plus 7, that's +3. A times -1/2 plus 1, that's +1/2, right? And this expression is equal to 0. So a is equal to 6, right? So a is equal to 6, b is equal to 1, right? So this definite integral is equal to 1/2 times, from 0 to 1, we have 6 over 2x plus 1, right? Plus 1 over x plus 1 dx, right? So we can find our antiderivative of this expression and this expression separately, right? So let's find our definite integral from 1 to 1. 6 over 2x plus 1, that's 6 times integral 0 to 1, 1 over 2x plus 1 dx, right? That is equal to 6 times, here, since we have 2 here, that has to be 1/2 times natural log 2x plus 1, right? Be careful with this 2, okay? If we have 2 here, then we must multiply by 1/2, so that the derivative of this is equal to 1 over 2x plus 1, right? Let's write the derivative of this. That's going to be 1/2 times 1 over 2x plus 1. And by the chain rule, we have to multiply by 2, the derivative of 2x plus 1, right? So that this cancels out, and we get 1 over 2x plus 1 here, right? Does that make sense? So let's erase this. Okay, now we're going to find the antiderivative of this. Okay, so that's easy, right? 0 to 1, integral 1 over x plus 1 dx. That's just equal to, I'm sorry, we don't have enough space, right? X plus 1, right? So if we rewrite this antiderivative of this expression, that is equal to 1/2 6 times 1 over 2 natural log 2x plus 1 plus nat log x plus 1 from 0 to 1, right? So that is equal to 1/2. This is actually 3, right? 3 nat log, if we substitute 1, that's a nat log 3 plus nat log, substitute 1 here, 2 minus, if we substitute 0 here, that's nat log 1. 0 here, that's nat log 1, right? So nat log 1 is actually equal to 0, but let me write it. Minus nat log 1. So this is a 0. This is a 0, right? So that is equal to 1/2 times 3 times the nat log 3. 3, actually we can write 3 over 2. 3 over 2 nat log 3 plus 1 over 2 nat log 2. All right? Or we can actually simplify furthermore. I'm going to write right up here. That's 1/2 times 3 times the nat log 3. Like 3 times the nat log 3, right? Plus nat log 2. So that is equal to, using log of property, 3 to the power of 3 plus nat log 2. That's a 27, right? So 1/2 nat log. If we have 2 log with plus, then that's going to be multiplication, right? So 27 times 2, that's nat log 54. Okay?